Hi everyone. In last session, we have discussed about stability of different carbocations. Today also, we'll discuss about stability of carbocations. Some more examples. Here, in last class, lastly, we have discussed about benzyl carbocation, allyl carbocation, and secondary carbocation order I given. Now, only different benzyl carbocations. Otherwise, benzyl is nothing but phenyl methyl carbocation. Phenyl methyl. So, like this, we can write phenyl. This is phenyl group C6H5. Here, if it is CH2, then we can say methyl. This is phenyl methyl carbocation. Otherwise, we can say it is benzyl. It is benzyl carbocation. Benzyl C plus or carbocation. Because of its resonance, it will get more and more stability. How we can write resonance forms? Yesterday also I written resonance forms of these benzyl carbocations. When this pi electron shifted here, we get like this double bond here, CH2 carbon or CH2 positive charge is compensated, and here this carbon gets positive charge because electron density decreases at this carbon. Then these are the already present bonds. Then to compensate this positive charge, again these pi electrons shifted here. So we get one more resonance form like this. This carbon gets positive charge. This is as it is CH2. Then similarly, this electron pair, pi electron pair shifted from here to here to compensate this positive charge. Here this carbon gets positive charge. Here double bond. Here double bond. CH2. Then lastly this bond again. This pi electron shifted from here to here. Like this, we get 5 resonance forms, including first and last. We get 5 resonance forms for this benzyl carbocation. Otherwise, we can say phenyl methyl carbocation. Due to resonance, due to resonance, it will get more stability. Stability of benzyl carbocation. Benzyl C plus is due to resonance. 5 resonance forms are there. Here we have to remember one thing. Here number of resonance forms, number of resonance forms is directly proportional to stability. This you have to remember. Here benzyl carbocation has how many? 5 resonance forms. Similarly, if you take like this CH, here positive charge, and one more here I am writing. This carbocation is nothing but diphenyl methyl. Diphenyl methyl carbocation it is. Diphenyl methyl carbocation C plus. See here for only one phenyl group, how many resonance forms you have? 5. For 2 phenyl groups, how many it will be? 10. So that compared to benzyl carbocation, diphenyl carbocation is more stable. Then similarly, we have triphenyl carbocation. Here C plus. Here we are writing one more phenyl group. Here one more. Like this we have triphenyl. This is the triphenyl carbocation. Triphenyl methyl. Triphenyl methyl carbocation. So here how many? Total 3 phenyl rings are there. For one phenyl ring, like this 5 resonance forms. For 2 phenyl rings, here we can expect 10 resonance forms. Here for triphenyl methyl, 15 we can expect. 15 resonance forms. 15 resonance forms we can expect like this. For understanding in this way I am explaining. So among these three, which is more stable means which have more resonance forms that have more stability as per this statement is given. So what is the order of stability? Here I am writing order of stability of these. Order of stability of this is first benzyl. We can write this benzyl group as phenyl group as pH phenyl CH2 plus this also similar to this only. So pH I am writing here space problem. So pH CH2 plus this is less stable. Then diphenyl methyl here one more pH. Then pH C here plus here one pH here also one pH. This is the triphenyl carbocation. So this is the order of stability for benzyl, diphenyl carbocation, diphenyl methyl carbocation, triphenyl methyl carbocation. This is one thing. So when number of phenyl groups increases on C plus, then number of resonance forms increases so that stability also increases. This is one thing. Then on benzyl group or benzyl carbocation, if electron releasing and electron withdrawing groups are present, how it affects on stability, that also we'll discuss. So effect of electron withdrawing and electron releasing groups on stability of carbocation. Which carbocation? Benzyl carbocation. On benzyl carbocation, if electron releasing groups are present, what happens? Electron release withdrawing groups are present, then what happens? See here, for example, this is benzyl carbocation. So before that, I am writing heading here effect of ERG and EWG. ERG means electron releasing groups. EWG means electron withdrawing groups on stability of benzyl carbocation. Benzyl carbocation. C plus I am writing means benzyl carbocation. See here on benzyl carbocation here CH2 plus. So as per the concepts, whenever the charge species is formed, if you compensate that formed charge, then only it will get stability. More compensation of the formed positive charge, it will get more stability. Less compensation will give less stability. Stability depends on how much it is compensated. More compensated or less compensated. See benzyl carbocation here it is normal already because of their resonance it has some stability. If here OCH3 group like electron releasing, this is ERG. This is ERG means electron releasing group through which effect resonance effect or mesomeric effect. How we can get this group is electron releasing group? In previous sessions already we have discussed. Whenever the atom which is directly attached to benzene ring carbon carries lone pair of electrons, that is nothing but k atom. K atom is nothing but the atom which is directly connected to benzene ring carbon. If that k atom contains lone pair of electrons, always it acts as electron releasing group. So here electron releasing group is present. What happens here? These electrons, this lone pair of electrons are shifted to ring. Ring is now activated. So these electron releasing groups otherwise called as ring activating groups because the electron density increases in the ring. When electron density increases in the ring, it is activated. So that the electron density which is present in the ring now move to C plus. So that the positive charge which is present on carbon will be compensated. So that this is more stable. This is more stable. It is more stable due to plus R effect. plus R effect. Otherwise, we can say plus M effect. Then here I am writing normal benzyl carbocation. Here CH2 just plus. There is no any electron withdrawing group. There is no any electron releasing group. So that it has its own stability. But compared to this, its stability is less. So that this is the order of stability for these two. This is directly benzyl. This is orthomethoxy benzyl. This is benzyl. Now one more I am writing here CH2 plus CH2 plus. So before this, I am writing one more here. Here only I am taking CH3. CH3 also methyl group. Any alkyl group, if present on benzene ring, methyl group or any ethyl group or any alkyl group, the carbon must be with minimum one hydrogen. Then it acts as always electron releasing group. It is ERG. It is ERG. But this ERG is due to electron releasing nature is due to hyperconjugation. It is hyperconjugation. Hyperconjugation effect is not stronger. Hyperconjugation effect is weaker compared to resonance effect. Weaker compared to resonance effect. So that here more number of electrons will not be transferred to ring. Here more and more number of electrons are transferred to ring. So that ring is more and more activated. So more electrons transferred to CH2 plus. But here CH3 also electron releasing group, but it is due to hyperconjugation. Hyperconjugation effect is weaker compared to resonance effect. So more electron density will not be moved towards ring. So that no that much of electron density move to CH2 plus compared to this. Here also electron density move to CH2 plus. The CH2 plus is compensated, but not this much compensated. So that it is also stable I am writing. It is stable. But it is more stable, this is stable. Then here now benzyl carbocation normal as it is because of its 5 resonance forms it is having some stability. Here one more benzyl carbocation I am writing CH2 plus. Here I am writing NO2 N double bond O here this is nitro para nitro benzyl carbocation. Para-methoxy benzyl carbocation, para-methyl benzyl carbocation. This is just benzyl carbocation. This is nitro, para-nitro benzyl carbocation. But here this is the EWG, electron withdrawing group. This is here electron releasing group. This also electron releasing group. Here this is EWG, electron withdrawing group. Why it is electron withdrawing group? How we can get this idea? So this also in previous sessions I given. Whenever key atom which is directly connected to benzene ring carbon carries multiple bonds with more electronegative atoms, then this more electronegative atom attract the electrons towards itself. So at nitrogen or key atom electron density decreases, so that these electrons are shifted here. That indicates what? Electron density is moving to this NO2 group from ring. So that like these groups are called as deactivating groups. Ring deactivating groups. So whenever this ring is deactivated, whenever in the ring electron density decreases, so that this can accept electrons from CH2 plus. So that here instead of compensation, more and more electron density, more and more electron density decreased on CH2 plus. That means positive charge is developed more. Positive charge instead of compensation, positive charge is developing, so that it will get more and more instability. So it is ERG. It is due to minus R effect, minus R, otherwise minus M effect, mesomeric effect. So it will get more instability. Here I am writing more but unstable, more unstable, more unstable due to again what here positive charge on CH2, positive charge on CH2 plus developed instead of compensation. instead of compensation. So these are the reasons. Here only I written reasons. So from this you can expect now. So here more compensation of this positive charge, so it is more stable. Less compensation, so it is somewhat less stable. Here no compensation, there is no development as it is, so that it is more stable than this one. Otherwise, methyl benzyl carbocation is more stable than benzyl. Benzyl is more stable than nitro. So there is questions they may ask. Here ERG carbocations are more stable than EWG carbocations. This you have to remember. Whenever electron withdrawing groups are present, stability decreases. Whenever electron releasing groups are present, stability increases. So this is important thing. This is about effect of ERG, EWG on stability of benzyl carbocations. Then we have some more carbocations like vinyl carbocation and phenyl carbocation. Vinyl carbocation and phenyl carbocation, these are unstable because there is no possibility for resonance. There is no possibility for resonance because that particular double bonded carbon only its positive charge. So vinyl and phenyl, these carbocations are very unstable compared to these because of no resonance. See next vinyl, vinyl carbocation and phenyl, phenyl carbocations are less stable, otherwise unstable due to no resonance, no resonance or no any other uh, electronic effect also. See here CH2 double bond CH, on this carbon there is a positive charge. This is vinyl. This is vinyl carbocation. So directly double bonded carbon only carries positive charge, so that no resonance. Resonance must be in conjugated system. This positive charge must be after one single bond, means here CH2 double bond, then single bond. Here if positive charge is there, then this will come here. That is resonance. Otherwise there should be conjugation. For resonance always one condition is conjugation. Conjugated system must be there, but here there is no conjugation, so that there is no resonance. Phenyl means what? Just now written pH. Here this carbon now gets positive charge. This is phenyl carbocation. Phenyl carbocation. These are unstable. These are unstable due to no resonance. But compared to primary, see here CH3, CH2 plus I am writing, and one more CH3, CH, here positive charge, double bond, here CH2. This is vinyl only. This vinyl carbocation, but secondary. This is primary carbocation, this ethyl. And here CH3, CH, here positive charge, CH3. This is secondary carbocation. Secondary carbocation, but not vinyl. It is secondary, otherwise isopropyl carbocation we can say, otherwise secondary propyl carbocation. So among these, order of stability, order of stability is like this. This is more stable than this one. This is more stable than this one because here plus I effect is there, and also 6 hyperconjugated forms also we can write. Here plus I effect with respect to this, and it is secondary. That too here CH sigma electrons again in conjugation with the positive charge. So that here also we can expect hyperconjugation. Here only 3 alpha hydrogens are present and plus I effect is present. So that here this effect is here methyl group 3 alpha hydrogens, here 2 alpha hydrogens. So that here also we can expect a hyperconjugation, here also we can expect a hyperconjugation. So here only one side. So that primary carbocation is less stable than vinyl carbocation, which is secondary, is less stable than secondary carbocation which is related to both alkyl groups, this side and this side. Here also secondary, here also secondary, but difference is here double bond, difference here both the methyl groups. This is another thing. Then next, based on electronegativity concept, carbons, different types of carbons, triple bonded carbons, double bonded carbon, single bonded carbon, sp2 carbon atom, sp3 carbon atom, or sp carbon atom, So here electronegativity depends on electronegativity on carbon atom. Depends on electronegativity on carbon atom. We have different order of stability. We have different order of stability. See here, triple bonded carbon if carries positive charge. Here H. Then H you can take any group also you can take. Similarly here double bonded carbon carries positive charge. Here hydrogen, here a group. Same group you should take. Then here C single bonded carbon atom, here CH2 plus. Here 3 bonds, here 2 bonds, here 1 bond. So among these, which is more stable? If all these are similar groups, Here hydrogen I am taking, here also hydrogen I am taking, here also 3 hydrogens. See here, this is a triple bonded carbon atom and which is more electronegative. So as per general concepts, more electronegative atom will not accept positive charge. Even though more electronegative atoms means like oxygen also, oxygen, nitrogen. If on oxygen atom, if positive charge is present, it will not get stability. But same, more electronegative atoms can accept negative charge. More electronegative atoms will not accept positive charge. So this carbon is more electronegative. Here this carbon is less electronegative compared to this carbon. Here least electronegativities. So what is the order of stability? This is very less stable than this one. This is less stable than this one. This is another concept. So different questions they may ask. So all concepts I am giving. So you have to apply these concepts on questions. In questions, they may not give only this order. Just now I given one more order. They may not give only that particular order. Mixed orders they may give. We have to apply that particular concept. Okay. Then whenever on positive charged carbon atom, the other groups with the lone pair of electrons is present. Otherwise heteroatoms. Here C positive charge. Here maybe it is CH3. Then C positive charge. Here O. One more, any bond you can take, CH3 you can take, or any. So here this is heteroatom. But electron pair is present. So because of this lone pair of electrons and because of this positive charge, these two are separated by a single bond. Means here this conjugation is in between lone pair and positive charge. So that lies we can write resonance. Here CH3, here C, here one hydrogen we can write CH double bond O CH3, and here this oxygen gets positive charge. So like this, whenever heteroatom with lone pair of electrons is directly bonded to positive charged carbon atom, also gets stability through resonance. It is also the stability also due to what? Resonance. This is more stable due to resonance. Not only this, here if you take chlorine or nitrogen or phosphorus, but the adjacent atom must be with lone pair of electrons, then you will get stability. One more important thing here is acyl carbocation. Acyl means here R C double bond O OH. This is carboxylic acid. If here methyl group is present, then this is acetic acid. If you remove one hydrogen from this, you can get CH3COO minus. It is called as acetate ion. So if you remove this oxygen also from here, then we can say this is acetyl. On this carbon, if positive charge is present, we can say this is acetyl carbonium ion, otherwise acetyl carbocation. See here, instead of CH3, if R group is present, R C double bond O positive charge, then we can say this is acyl carbonium ion. Acyl carbonium ion also more and more stable, almost its stability is equal to tertiary butyl carbocation. Somewhat less maybe, but almost equal to tertiary butyl carbocation. It is also due to what? Stability. It is also stability due to resonance like this. See here I am writing last thing here, R C double bond O. Here lone pair of electrons are present on oxygen. Acyl carbocation means here CH, this carbon now gets positive charge. This is called as acyl carbonium ion, otherwise carbocation. Acyl carbocation. So this lone pair of electron now shifted here. So R C triple bond O, R C triple bond O. On oxygen, positive charge. It is also due to resonance. Due to resonance, its stability is almost equal to tertiary, means tertiary butyl carbocation. Remember, its stability is almost equal to tertiary butyl carbocation, equal to, one more time writing, tertiary butyl C plus, tertiary butyl C plus, or tertiary butyl carbocation. So this information also required. So now, as per this explanation, now I am giving overall order of different carbocations. So we have discussed many orders here. If you mix all those orders, we will get one particular order. So that order I am giving here, order of stability of different carbocations. Order of stability. Among these, they may give in examination, they may give 4 or 5, and they throw those carbocation into question, and we have to solve that. They may ask, for solving, they may ask question with respect to increasing order of stability or decreasing order of stability, otherwise among those which is having more stability, which is having less stability. So like that questions they may ask. So that here overall order of stability, overall order of stability of various carbocations. Overall order of stability of various carbocations. Among these, first one is triphenyl, pH3C plus, triphenyl methyl carbocation. After this, pH twice CH. This is the diphenyl methyl carbocation. Then tertiary butyl, CH3 taken thrice I am writing, C plus. Tertiary butyl, how we can write? CH3, C, here CH3, here also CH3, here positive charge. Triphenyl means pH, C, pH, here pH, like this you can write. Just now we have discussed about this. So like this we can write. Short form writing or fusel form writing. CH3 taken thrice, C plus, then benzyl carbocation, pH CH2, benzyl carbocation. After benzyl carbocation, we have secondary carbocation, CH3 taken twice, CH plus. This is more stable here. This is more stable than allyl. CH2 double bond, CH, CH2 plus. This is allyl carbocation. Then after allyl, this is secondary, means R, allyl vinyl only, R, CH double bond, CH2 positive. This is vinyl, but vinyl secondary. vinyl secondary carbocation, then primary CH3 CH2 plus, then methyl carbocation. Methyl carbocation is more stable than phenyl carbocation. Phenyl carbocation. Ethyl, then methyl carbocation. Before this, we can write phenyl. Phenyl means pH positive charge. It is more stable than methyl carbocation. Methyl carbocation is more stable than CH triple bond C carbocation. Then after it is more stable than vinyl directly. Otherwise, up to here you can. So this you have to remember. Order of stability of these carbocations. Remember different carbocations. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 I given. Among these 11, in examination they may ask 3 or 4 from this they pick up and they throw into question and they ask which is having more stability, which is having less stability. Otherwise, what is the increasing order of stability or what is the decreasing order of stability. So this is the overall concept related to carbocations. One more very important thing here is carbocations generally participated in rearrangement reactions. This is important. Carbocations generally, if possible, generally participated in rearrangement reactions. Rearrangement rearrangement reactions. For example, due to some reason, it may form primary carbocation. But after shifting hydrogen, otherwise after shifting methyl group, if it gets a more stable carbocation than that, then there is a rearrangement takes place. For example, here CH3, here CH2, then CH2 plus. This is the carbocation is formed in intermediate stages in one reaction. But the product formed is not due to this because for this there is a possibility to get one more carbocation which is more stable. This is the primary C plus carbocation, less stable. It is less stable. But here due to rearrangement, you see this among these two hydrogens, one hydrogen I am writing in this way. So here this hydrogen shifted from here to here by taking its two electrons. Means we can say it is 1 comma 2 H minus. H minus is nothing but what? Hydride. 1 comma 2 hydride ion shift. 1 comma 2 shift means what? 1 carbon to next carbon only. So that here we get CH3, CH positive charge and CH3. So this is a secondary carbocation which is more stable, more stable. So the product formed is based on this. If secondary carbocation is there, otherwise primary carbocation is there. One more example I'll give and conclude this session. One more example related to this. One more example here CH3, here C, here CH3, here also CH3 I am taking, but here CH2 plus. This also primary carbocation. This formed during a reaction, but this is less stable. This is less stable. So that the product formed is not due to this. Here as to get more stable carbocation. Here this methyl group is shifted from here to here. Means by this methyl group shifted from here to here by taking these two electrons. See, like this I written. These two electrons are moving with the methyl group. So we can say this is 1 comma 2 methyl negative charge shift. Methyl shift. This 1 comma 2 indicates what? That shifting is from one carbon to immediate carbon. So here we get CH3, C, CH3, here CH3. This CH3 is moved to here now. So that here CH2, then CH3. This carbon gets positive charge now. This is the tertiary carbocation. It is more and more stable. More stable. So that the product formed in this reaction is due to this carbocation. Like this, carbocations generally participated in rearrangement reactions. If possibility is there like this or like this, Then they first participate in rearrangement reaction, then after products are formed. So this is about totally the information related to carbocations. So this is very important. In next sessions we'll discuss about one more reactive intermediate, that is carbene ion, in the similar way. Okay. Stay home, stay safe. Thank you.